So far we talked about all the steps needed to create a DRBFM worksheet, and now we're trying to have kind of tips and tricks on how to develop your DRBFM worksheet as efficient and as complete as possible towards the success of your product development. So in arranging the change, basically we are interested in the change comparison list. So by this point, you already finished the visualization of your product. You already decided and already drawn or included down the difference between your old design and the new design. Now you go to step number 2 in the DRBFM worksheet, which is the change comparison list. So you're creating kind of a breakdown in a table format of all the change points that happened in your system. So the tips for the change comparison list, it's highly preferable to group the items. So it is preferred to group the items by system, by assembly, sub-assembly components, up to the smallest and the least detailed part in your system. We can go down here, you can see there's a system, and there's the assembly part, and there's the sub-assembly part, there's the individual part, and the reference from the exploded view. So in your exploded view, you have the old and the new design. When you compare the old design with the new design, then you broke down all the details in the new design. As we said before, you gave him number 1, number 2, 3, 4. You used letters, you used abbreviations as symbols to call out each component and subcomponent that could be a major concern or even a minor concern in the system. So you have your system. Let's say you have system ABC in this case. Then you have, let's say, assembly A1. In assembly A1, you have sub-assembly A12. Then you have individual parts 1, 2, 3, and so on. So you list them down, all subcomponents. So you have one system, you have many assembly parts based on your exploded view. You have sub-assembly parts, you list them down, and you have individual parts, you list them down. Then you start to say, okay, this one is referenced number 1 in the exploded view. This one is referenced A2, referenced B3, and so on. So that's how you do the change comparison list by system, by assembly, sub-assembly, and components. Then you list your components, you write down what is that component, in which category does that component belong. Then the changes, you have the base, which is the old design, what you had before in terms of dimensions, physical properties, chemical properties, any kind of property you could imagine, anything descriptive enough to tell you what happened in the past and what's happening now. Then in the new design, you say what's happening now. Then you reference, if you have a tab, extra tab for references, then you can say, go back to reference 1, 2, 3 to know more details about it. That's where you put more and more details. Probably the worksheet is too busy to put details in a line, in an Excel sheet, let's say, in a cell or so. So you can use a reference to detail more and tell more about your story of why that changes happen and what's the science behind it, what are the reasons behind it, and so on. Again, we are saying details, details, details. So you include advanced level of details in your description for the change comparison list. Any detail that could be helpful toward telling the story about the change, why it happened for that specific part or that specific assembly, then it is highly recommended to include it down. Then you want to tell what is the reason behind the change. Why did you want to move from the old to the new design? That you make sure to include either in change comparison list, or you can maybe sometimes for the more advanced explanations, you can save it to the change matrix, the one we learned about previously. And eventually you follow up the top-down approach in detailing. As I said, you go assembly, sub-assembly, part, and component. So you go top down, you have a wheel, then you split down the wheel into rubber, into rim, into bolts, into dimensions, into maybe chemical properties, material properties, into all the details about speeds and how much you can handle, durability test, and so on and so on. So that is how the sheet is looking like. You could do any other designs, but that's how it looked like in a standard form. You're having the system name, assembly parts, sub-assembly parts, individual parts, and reference from exploded view, the base design compared to the new design, and any external references needed to tell the story in more clear form. An example here, you're having the change comparison list in this case, and we simplify it here just for demonstration. You have item, you have the base design, which is the old design, you have the new design. Then you have like kind of reference letters in here telling you which is which. So you have the system, that's where the system is, right? That's the tank body. Let's say you're talking about the gas tank for a certain vehicle. Then you are mentioning the supplier here as a category, and the base design is abbreviation FTS, and the new is FTS, referenced as A in the exploded view. So here we have an item is the total capacity. So that's one thing. Total capacity was 61.3 liters in the previous design. In the new design, it's 66.2 liters. Now that's a change referenced in letter B. If you go back to the visualization of that exact DRBFM worksheet, you will find it talking about or calling out the tank body and telling you details about the total capacity. Then the nominal capacity, you're having difference as well, and the mass is going from this to this. All are called out. Minimum thickness, surface area, all these are physical properties. Then you tell your stories what's going on between the previous design compared with the new design. You can add extra comments as well. So he's saying letters from A to F, those physical properties apply to them. And the reason for change, the spec change for increased fuel capacity. So the car manufacturer is telling we need more fuel capacity. Maybe the car is consuming more fuel with a new engine design. Now you want to be able to let this car roll in full tank for 400 miles or 500 miles in total. So that kind of discussion you are talking about, just listing the details in your change points regarding the big picture and the main assembly. Now for functions, so after finishing comparison list, we learned that you go to functions list. Now you write for each part, what is the function that part is playing in your overall system. So for functions, you basically look at that change point, or for that component, you identify the basic purpose of each system, assembly, component, subcomponent. Then you identify the other functions considering the entire part life, like in terms of durability, and you consider all the customers and suppliers that are providing kind of sub-assemblies and components for that product. Then you identify the function while interfering with the surrounding parts. So you need to understand the part, where does it play a role in the system or in that specific assembly, and how does it affect all other assemblies or all neighboring functions, and how are the neighboring functions and environment is affecting that specific part. So those details are important in identifying the concerns in the change matrix in the future. Then you generalize, like you try to capture the big picture. You look at the system as a whole and you specify in details for as detailed as possible. But when you start in a big picture. As we said, it's a pyramid style, top-down kind of system. You try to look at the big picture, then you break it down in details and how does those components and change points interacting with each other and affecting durability, sustainability, and development of that specific product that we're talking about in the DRBFM review. The more details you have about your function, the better the DRBFM worksheet will be, and you can find more potential or confirmed concerns in your change matrix, which make your part eventually act better, and you will land to a more durable and trusted product. Then you add measurable parameters for evaluation. You can't just tell this product is helping the vehicle moving from point A to point B. That's too much generalized. So you want to say certain kind of physical parameters, as we said in the fuel tank example. So you can say fuel tank pressure is changing from A to B, fuel tank volume changing from 20 liters to 30 liters. So that's a measurable kind of parameter, and it's very important and help the experts giving you the best advice and recommendations possible when you start your design review meetings. Then you list the criteria component like item to measure, record, and inspect. Same thing. It's you're trying to land a measurable parameter to be able to perfect the process of DRBFM and try to capture all the concern points through the DRBFM process. Detailing function here, we have a general description. You have a fuel storage. Here we are telling the function or the requirement for the fuel storage. Then we say in the input internal pressure, the input is internal pressure of 108 kilopascal. Road surface vibration is this much hertz, and road surface interference. Then for pressure resistance, you're seeing pressure resistance, the input for it should be higher than 30 kilopascals with a check valve under 80C. So this way you're telling what is the fuel storage function or properties are, and for the pressure resistance you're telling exactly in measured parameters what is the pressure resistance is in this case.